Okay, there we go. We're set up. Okay, a couple things here. Today we should be able to get through the rest of our notes. With tomorrow being so kind of messed up as it is, we only got 20-minute class periods. We're probably, I'm still kind of working through this. Tomorrow we'll probably spend either time out in the shop demoing the lab, although again 20 minutes is probably not going to be enough time to do that. We'll probably stay in the classroom maybe and wrap up our notes in terms of like summary, questions, things along those lines. And then give you guys some opportunity to complete the note summary assignment, just like we did with the suspension system. That'll free up potentially Monday for us to be able to then go out in the shop, demo the lab, walk you through how to use the tools, how to set the vehicles up for inspection, and then we'll start having at her on that. And we'll give you guys at least 2 weeks before spring break to do that, and then probably honestly maybe a week or two after we get back from spring break to finalize that stuff up.
Feels like Monday again.
It feels like Monday again. Well, that's because you guys weren't here. Or at least some of you guys weren't here yesterday.
None of us were here.
Yeah, I was. That was super fun. Anyways, that was yesterday. No big deal.
Is there one?
Trying to think of what else I needed to talk about.
Any junior, you dumb.
The study guide. The study guide for the steering suspension unit. That'll be assigned to you in Google Classroom tomorrow. I'm still kind of putting some finishing touches on that, but it's going to be very similar to what we've done in the past in terms of 7 days, but that'll be due next week, Friday. Okay, where we left off? We left off on slide 14. We didn't even talk about this, I'm assuming? We didn't talk about this? Okay. So, with steering systems, whether it's a parallelogram or a rack and pinion, there are assists that we could provide for these steering systems that's going to help ease the load or the forces that need to be acted on the steering wheel in order to actually turn the wheels. Not too sure if you know this or not, but if you've never had a power steering system before, it's difficult to turn the wheel at low speeds. Okay, mostly due to the fact that there's a lot of friction between the rubber tires and the ground, right? Yeah. And the vehicle weighs several thousand pounds, so there's some forces there that you have to overcome. Unfortunately, it makes steering the vehicle challenging because you have to be pretty physically adept to do that. Back in the day, I had a 2007 F-150, and the power steering went out on that, and it made parking in the parking lot out here challenging, to say the least, because I was grabbing the steering wheel with both hands and literally putting my body weight into it just to get it to turn, which was obviously not fun. It wasn't lined up either as best as it could be, right? Now, at the point in time, my wife would not be able to drive that car or that truck because she wouldn't be able to handle that. Now at higher speeds, because the wheels are rolling, it's a little bit easier to handle because you don't need as much forces as you're driving it. But
no shit.
The steering systems are designed so that way if you're traveling long distances or a long period of time, you're going to fatigue out pretty easily. Okay, our bodies are not meant to go through that. You're going to be sore at the end of the day. Quite literally, you're going to hit the bed and you're going to be zonked out because it's a workout. So, to help us keep our attention on the road as we're driving, we need the inputs on our vehicle to be as easy as possible. Okay, so that way my effort's not going into worrying about turning. It's more worried about the person that's not turning, that's over here, or the person walking their dog crossing the road. Okay, so regardless of what type of power steering system that we have, we're going to hook it up to either a parallelogram or rack and pinion, and that's going to reduce the effort needed to turn the steering wheel. Okay, now there's two main types of power steering systems. There's a hydraulic and there's an electronic. All right, we're going to spend a little bit of time talking about both. There are some clear advantages and disadvantages to some of these, and we're starting to see a very quick transition over to electronic power steering because of its added benefits. Know what I mean, Mason?
Yep. Jetsky, did you have with one hand or two hands?
That's irrelevant to what I'm talking about right now.
I'm just curious. It may change how I look at you as a person.
Oh, you know what? I don't even use any hands. That's how good I am. I use my forehead. Try to get that image out of here now. You're gonna be driving home tonight going, how does Getsky do that?
No, I'm not even gonna think about it.
All right.
38 seconds.
Hydraulic power steering systems. Let me pull out a hydraulic power steering system. Come on. There we go. Hydraulic power steering system. This is pretty much it. Uh-oh.
Why are you continuing to let it spill? Do you know how gravity works? You're gonna flip it upside down and it stops spilling.
Okay, let me get more of it then. Okay, that's gonna be slippery, by the way.
You act like you just like harmed me. Like it's not my classroom. I don't have to clean it.
Why would you clean anything anyways?
Bro.
Most students are gonna make a mess, they don't clean it up anyways. Anyways. Power steering system, hydraulic power steering. You see here that I was already dripping out hydraulic fluid. That's kind of one of the disadvantages. That was one of the disadvantages to this particular system. Okay, we're going to use automatic transmission fluid in most cases. It's going to be filled up with a reservoir. It's going to then go to a pump. That pump is being run by the serpentine belt. So that is quite literally being powered by the engine. So we are parasitically loading or drawing off of that engine some horsepower in order to run this system. It pressurizes the fluid, which then goes to our steering rack or our steering gear in a parallelogram system to again assist and ease our turning. Okay, so the machine is actually adding to our effort, okay, whether we're turning left or right. Okay, then that fluid then is utilized, the pressure is utilized, it goes back to the reservoir, and the whole cycle repeats itself. Okay. Now, this particular pump that's being turned can pressurize the hydraulic fluid through many different ways. Okay, we could have a roller, a vane, a slipper, or a gear type design. Regardless of what design it is, it's all going to do the same thing. Again, take automatic transmission fluid, pressurize it, force it through. We then take that energy and force to be able to turn the gears in the steering wheel as it's required. Okay? And again, serpentine belts are typically what drives our hydraulic pump systems. And again, part of the maintenance, part of the inspection process for our steering system is to actually go into our power steering and check the fluid. Okay, hey, do I have the proper amount of fluid? Is the fluid in good condition? Right? Is it low? Do I need to refill it? And we'll get more into this later, but one of the biggest things that most people don't do is they don't check this when this power steering fluid is low. Right? I start to turn, and then all of a sudden, I'm hearing this whining noise. Right? But it only happens when I'm turning. That's a key indication for you to understand that that's probably hooked up with your power steering system.
Where would you find that?
90% of the time, all you have to do is add more ATF into your system, and that cures the problem. Okay?
Automatic trans fluid?
Automatic transmission fluid. Yep.
Where would you find that reservoir?
Under the hood. Somewhere in the engine bay.
Mason?
Yeah, isn't that weird that transmission fluid is used to power your power steering system? Now, keep in mind, any liquid could potentially work, right? We could use motor oil as a hydraulic fluid.
I'm thinking viscosity would work very well.
You could use power steering fluid, but most manufacturers, ATF. Nothing special.
Then why did they make power steering fluid? For other
Marketing.
things?
They want to make money. Just throwing that out there. It's kind of fun.
We just throw water in there.
Okay, power steering uses both flow control and pressure relief valves in addition to a sensor which can signal the need for an RPM increase to the powertrain control module under heavy steering load at idle. Okay, so even though it's a hydraulic system, we still have electronics that are monitoring the pressure that's being built up and steering wheel angle sensors and all that stuff. So if I'm in a parking lot and I'm turning the wheel, okay, I need to build up higher pressure in my power steering system. Well, how am I going to do that? Well, how's the pump powered? Through the serpentine belt, which is hooked up to the engine. Okay, so now all of a sudden my computer system is going to key up my engine, one, to say, hey, I need more RPM out of my engine. Even though I'm not going anywhere with the wheels, I need to turn my power steering pump faster, pressurize it more, so then that way I get more assist. So again, this is common stuff that you would probably see, or maybe you don't even notice, but if you're in the parking lot and you're starting to turn your wheels at slow pace, and all of a sudden, hey, my engines are RPMs increasing. Why is that?
To turn the serpentine.
Okay, it's probably because your PSP sensor, power steering pressure sensor, is reading that it needs more pressure in order to create an assist. So it keys up the engine to do that, because that's what powers it. Okay, kind of fun. All right, and again, you can kind of see here a vane type pump. Okay, so in this case, this is going to come in through here. As this is turning, it's going to go out there. Right? Here's a pressure relief valve. If I get too much pressure, this is going to open up, just kind of like an oil bypass valve.
Yeah.
Right? And it allows some of that to go bypass the wheel, just kind of as a relief. Again, if I didn't have that, I could build up too much pressure, and then what's going to happen?
It's going to burst.
Yeah, hoses are going to burst, right? Things are going to collapse in on yourself, and then you're going to have all your ATF fluid leak out on the ground. Then you're not going to have a power steering system. So it's a way to protect your more expensive components, like your power steering pump. Okay, I would much rather be able to need to replace something less expensive, probably more convenient to replace, than something like a pump itself. Okay, which is always fun. All right, again, power steering hoses are going to be able to transmit fluid under pressure. So one of the things is, if we are looking at replacing these parts, you have to be cautious that this is a hydraulic system. Hydraulic fluid under pressure can cause significant injuries. Okay, it's not something to take lightly and just start pulling things apart and hoping that it's going to be all right. Okay? If you're not wearing safety glasses and all of a sudden you disconnect a hose and there's pressure behind that fluid and it gets in your eye, you're probably not going to have an eye anymore. Okay? Just straight up. Especially if it's hot. That's not going to be a fun time. Now, please understand, because again this is being pressurized up to 1500 psi, it's not a sneeze. Okay? And because if it's off of a hot engine, we can look at up to 300 degrees. So you're looking at like 3rd-degree burns. Instantaneous if this stuff gets on you. And it could be spraying everywhere. So again, the proper precautions are very important when dealing with these types of systems. So you need to be able to identify what system you have. So if you go to work on it, you can obviously take the proper precautions. Okay? And again, in most cases, engine's off, engine's not turning the serpentine belt, so the pump is not actually pumping anything. That's most of the time probably what you need to do. But then obviously if you disconnect hoses or of any type, you got to make sure that you understand that there's going to be fluid in the lines. Okay, it's not just in the reservoir. It's in there all the time. You're gonna have leaks, so you need to be prepared for that. Okay, and ATF is slippery.
How funny would it be if I walked down that with belt?
That'd be your own fault because you know it's there. All right, electronic power steering systems. Again, this is kind of taking over in terms of the preferred method because A, I don't need to actually run a pump off of the engine, so I actually get to take all my horsepower that my engine is producing and send it to the wheels, which means better gas mileage. That's kind of the thing nowadays, right? We need to make sure that we can up our MPG. This is the best way to, this is one way that we can do that.
Gallons per mile.
Okay? We're not parasitically drawing that off of our engine. Second of all, it's much more compact, much more user-friendly, if you will, much more reliable. Okay, I don't need to check on fluid levels on an EPS system. It's an electric motor that's hooked up to my computer system in the car. So as I'm turning my wheel in low-speed situations, the computer's going to sense that, right? It doesn't need to increase RPM off the engine. It just simply adds more amperage into that motor to help you turn it. Okay? Which is pretty fun. So typically speaking, we're looking at a 12 volt or maybe even a 42 volt electric motor that's mounted inside my rack and pinion. EPS can only be utilized with a rack and pinion. You will never find one on a parallelogram system. Okay? So just be cautious of that. Again, when you're going out there in the lab and you're identifying the vehicle, hey, this particular one's got a parallelogram. Awesome. You immediately know that it has to have a hydraulic power steering system. Okay, immediately. Because EPS cannot be on it. All right, either it can be mounted to on the inside where the steering gear is at, or maybe even on the intermediate shaft somewhere. Again, it's more compact, so I don't need hoses, reservoirs, pumps. It's just an electric motor. And it's nice because, again, it can be computer controlled. Computer is going to create more amperage to flow through there. So it's less likely to break down. All right, so you can kind of see here the circuit layout, right? Here's my rack and pinion. Okay, right down here is where the steering wheel would go in. So as I turn this, right, I got a steering wheel sensor. Here's my electric motor hooked up on the inside of this, basically, again, assisting the ability for this thing to turn. My pinion gear is right down here, and then my rack is going to be sliding back and forth. Okay? So it's kind of like, you know, if you're learning how to drive and you're like at the little arms and you're like, yay! And it's like mom or dad coming along and grabbing the steering wheel and helping you turn that. Not that I would advocate for small children steering cars, but you kind of get the mental image of that. Alright, so again, here's my ECU. That's my computer. Alright, I've got pinion angle as an input. Alright, I've got steering wheel angle sensor, road speed sensor, vehicle speed sensor coming off of the transmission. So I have multiple inputs coming into the computer. So the computer knows exactly what speed you're at, what you're turning, what the forces are acting on, all this sort of stuff. And then it can then output information to that motor to better assist you. And again, it can do that quicker too. So you're not just simply relying on a reaction force from the hydraulic system. It's able to change that. Mason, you had a question or no?
No.
Okay. All right. Again, here's another fun part about this scenario is EPS can change the effort based off of low speeds versus high speeds. Because again, if your wheels are running down the road at 70 miles an hour in a straight line, you don't need additional steering assist because you're going straight. You're not turning that wheel. Okay? It does not take a lot of effort from the driver in order to do that. But in parking situations, when the vehicle is going slow or stopped, you're turning the wheel. Again, you can take two fingers and grab that wheel and turn it. It's going to feed into that and assist you. So again, the ease of the effort from the driver is greater. So I get less fatigue. I can be more precise, right? My parking is going to be better, which is obviously not going to only affect my vehicle and me, but also those around me. Okay, I can maneuver in tight spaces better. I'm not backing up and going forward a whole lot. Now, in terms of technology and the advancements of technology, EPS system is a requirement in order for kind of this future stuff like self-parking. Okay, one of the biggest things is actually developing the skills in order to park successfully, like parallel parking. Those of you that have your driver's license, did you actually have to do like a parallel park as part of your exam?
No.
No. Okay, guess why they don't have you do that?
Because nobody parallel.
Because you'd fail. Okay, because again, the idea is that that is a skill that's developed, that you learned through driver's ed in years past.
Okay. I've had my license for 7 months, and I don't think I've ever parallel.
Correct. It's not something that typically is done anymore. But I'll guarantee you, there's going to be a point in time where you're going to need to parallel park, and you're going to be like, nope, and you're just going to drive around and find a different parking spot. Okay, just because you won't know how to do it successfully. Now, the fun part is the manufacturers realize this, and they say, you know what would be really cool? Is if we could have the car parallel park itself. Right? So they've actually programmed this in, and it's on modern day cars. So what ends up happening is you literally pull up, and it shows like a little picture on your little dash, so then you're driving up to the car next to you that you're parallel parking to, right? Typically, we line up the mirrors on the cars, and you go, okay, I'm ready. You literally hit a button, hands off the wheel, and the car will back up and park itself, and you just get out.
What do you think happens if you like try to grab the steering wheel?
There's probably safety features in, right? So again, there's a steering wheel sensor, angle sensor, so if it senses that you're grabbing the steering wheel or there's resistance on that, it's probably going to abort the situation, right? It's just going to say, oh, you're taking over, you must see something I don't see. It defaults to the driver. Now, the fun part about this is this can parallel park better than you can. It can probably parallel park better than I can.
It probably is.
Okay, and I've done parallel parking before, right? That's because the cars have radar now. It has cameras. It can literally see the car behind it and the car in front of it, so it knows exactly how to back up as far as it needs to. You don't need someone on the outside of the car going, come on, come on, come on. Oh, you're this close. Okay, stop. By the way, have you guys ever done that before? Like you're helping your mom or dad back up a trailer and you're like, oh, this far away, this far. Nope.
No,
Man, I had to do that all the time as a kid.
We got like these things called backup cameras.
Yeah, I know. Now, nowadays we don't need that because you have backup cameras. My dad's got a trailer, right? He's backing up now. He doesn't even need me to line up the tongue with the ball to get that to go. He can literally just back up. He's got the camera. It's got assist. Whoop.
I bet your trailer doesn't.
He
have
puts
that
it in
now.
park, and then all of a sudden we just lower it down and go. It's so much more convenient. It's ridiculous.
Does your trailer have backup camera?
Well, the fun part is well, I'm not even going to get into this, but ADAS systems with cameras, actually with LiDAR, maps out your surroundings. So typically with like, I know for a fact Chevy's got this, where you hook up your trailer, and you can actually hit a button, and it can see behind the trailer, even though it doesn't have a camera on it. How is that possible? It's because the truck has a camera, and it literally was taking pictures and mapping out the environment as you were driving through it.
What the?
So then that way it can project that behind the trailer and give you an idea what's going on. So the technology, folks, is beyond anything that you can potentially even comprehend. This is just a very simple thing, and this has been around for many years now, okay? Which is kind of fun. Now, this also, the self-park is not only, that's just one piece of the puzzle. You have like lane assist, right? You're driving down the road. You've got your lane. You want to be in the middle of that lane with your cruise control on. Awesome. You got cameras that are actually watching the stripes. You got the radar going out in front of you, behind you, looking at the various different vehicles. And if you are distracted and you are starting to depart your lane, guess what happens?
It buzzes and pushes you back.
Yeah, the car is going to notify you through various different things and interactions, right? They even got like little buzzers in the steering wheel. And it literally can take over your steering and force you to go back in without you needing to turn anything on the steering wheel.
There's also, I don't know, this is all just cameras and sensors, but if you have your cruise set and you catch up to another car,
Yep.
it'll keep you at the right distance.
Yep, adaptive cruise control.
It sucks.
Yep.
On 45, there's a turn, it's a turn, but you can also go straight. And if there's ever somebody going straight, like slams on the brakes.
Yep.
Because it thinks you're gonna run it back.
Yep. So there's definitely still room for improvement on that, but with artificial intelligence, we'll eventually end up getting there. It's interesting the fact that this stuff is happening in front of our eyes, and it's conditioning you to trust it, because it's like, oh man, I don't even have to worry about going in the ditch anymore on a snowy day, right? It's conditioning you to eventually, in a world where there won't be steering wheels, it's conditioning you to trust the fact that this computerized systems are actually better drivers than you are, because it can see more than you can. Okay, it can understand what's going on faster than you can. So that's just kind of one of those things. But it takes time, because the humans are the dumbest link in that whole situation, right? And here's the even worse part of things, or I wouldn't say worst part, here's the benefit to you. If you are looking at getting into this as a career field, right, these are the types of situations that you are going to now need to diagnose. You need to understand how these systems operate, because eventually you're going to get somebody that brings their vehicle to you for service, and they're going to go, hey, I need my bumper taken off because it cracked. Awesome. How expensive is that? Well, the bumper's dirt cheap. It's $25. Awesome. So why in the world then is my bill $3,000? Well, whenever you take that bumper off and you're replacing it, now you have to readjust all the cameras, all the radar, everything along those lines. Because if you don't do that, your car is going to be looking off into the ditch expecting that's where you're going down the road, and it's not going to be able to have all of those features in order to be able to drive the car. It's called ADAS, Advanced Drivers Assist Systems. You know how we have TPMS systems, tire pressure monitoring systems? Hey, I know when my tire pressure is low, and it sends an electronic signal up to the computer and it gives me a warning, so I know when to fill up my tires. Think of it like that, but more advanced, so that way you can actually drive straight down the road. So understand that it's not just simply putting the rack and pinion in and out and reinstalling tie rods. It's more nerdy than that. We're literally hooking a computer up to the system and reprogramming it to understand. We're interacting with that computer. Okay? So you really do have to have a higher level understanding of these systems, so when you interact with it, you can do a perfect job. Okay? Because if that camera or radar is off by 1%, that could mean a whole bunch of things. Right? I'm not going to get into it because, again, it's way too advanced for a high school class. We don't even get into it in Auto 2. Anyways, electronic power steering system can again vary boost to match steering assist conditions. Again, it's always rack and pinion, okay? Which means my alternator now, because I'm putting out higher current, probably needs to be a little bigger. Some vehicles actually have multiple alternators, okay? And that's where we're really getting our power from in regards to running the vehicle. Now, the fun part about this is, unlike a hydraulic system, right? Hydraulic system requires the use of the engine to drive the serpentine belt, to drive the pump, to pressurize the hydraulic fluid in order for you to have power assist. Well, what happens if you're driving down Highway 41 at 70 miles an hour and the engine cuts out? How much power steering do you have at that point? Zero.
Actually, you probably...
Yeah, what's up?
Isn't the power steering pump connected to like the water pump?
Sometimes the water pump is run off of a serpentine belt, yes. But they're not, they would only be linked up through that serpentine belt. So if let's say your power steering pump seizes up, which causes your serpentine belt for whatever reason to freeze up, that could cause your water pump not to work, right? Could cause your alternator not to work. Doesn't cause it stops your AC system. But the likelihood of that happening, not much, because again, that engine is going to be able to easily overpower that. Granted, if your serpentine belt snaps, that's not good. What I'm trying to get at here is this. I lose my engine power, I lose my power steering. On an electronic power steering system, because of this electric motor that's hooked up to my battery, even if my engine stalls out, or even if my engine is off in the parking lot, I can still have assist, because it's electronic. Okay, so that's kind of fun. So I'm going to have that electronic power steering system as long as I have voltage that I can drain from that. And again, typically that's coming from our alternator, but if the engine's off, our alternator's not on, so I still have a backup battery. Pretty cool stuff. All right, anytime that we're doing steering suspension inspection, best practice is to make sure that the vehicle is on a level surface. Okay, we don't want to be on a slope of any sorts, left to right or front to back. Okay, we want to be on a level surface. And by default, alignment racks, when they are installed, must be level. Okay, that is part of the condition of when they are installed. They have to be level. So regardless of the slope on the garage floor that it's installed on, it's level. So more often than not, the best way to do steering and suspension inspections is on alignment rack. Okay. Also, the good news is when it's on an alignment rack, it's driven on, which means all the suspension and steering system is loaded by the weight of the vehicle because the lifting points are the wheels of the vehicle. And again, we can also perform a wheel alignment, which is a must if and when we are replacing or modifying our steering and suspension system. So it's all right there anyways, so you might as well do it on the system that's designed for that. Okay. Now, again, understand that whenever you do our inspections, we want to make sure that the weight of the vehicle is on the suspension system. We want to treat it as closely as it would be as if it were driving down the road. Okay? But before we even get into replacing stuff or diagnosing potential issues with our steering suspension system, the first phase or the first thing we want to do as techs is to perform a road test. Okay, the customer drops off the car. Hey, I think I have an issue with my steering. Awesome. Before you even bring it into the shop, you're going to go get the keys. You're going to go drive it. You're going to try to replicate what the customer is informing you or communicating with you in terms of what they perceive as the problem. Okay, you're going to try to replicate that. So as a tech, you need to understand how all of these systems work together, what kind of noises are coming, are going to be made, where that noise is coming from, what might be inducing those noises. Okay, so you're not just driving down the road straight, you're turning the wheel, you're listening, windows are down, right? Hey, when I turn left, I hear this particular type of noise, a whining, a squealing, a growling, as opposed to turning right. It only happens while it's braking or accelerating. Okay, there's all these things that you need to roll through and basically create a checklist. Here's the fun part. Sometimes you might not be able to create or recreate the problems or issues that the customer is complaining about. Right? Maybe it's only very intermittently that happens. Okay? So it's probably best to actually have the customer in the car with you as you're driving it around so you can be communicating with them. You know, they can tell you, oh, hey, there's the noise I was hearing, or do this, right? Sometimes, and this has happened before, sometimes the customer will be making a complaint about a noise, and really it's not anything significant. It's nothing that would be a cause for concern or added time investigating it, right? They might just be hearing something that was always there, but then just made conscious of it because they didn't have their music turned up to 3,000, right? Just something to think about. When we actually take a look at our power steering fluid, not only do we want to take a look at the level of the power steering fluid, but we want to also take a look at the color. ATF is dyed red. Is the power steering fluid red? Or is it brown? Or is it black? That tells you the condition type. What does it smell like? ATF has a very particular smell. Does it smell like it was burnt? Like it was put on a stove top and left there for too long? Okay? Does it feel slippery? Again, steering system complaints can come in a whole bunch of different shapes and sizes. These are just a small list of things. And again, we have to understand that these are not exclusive to just steering problems. It could be a wheel alignment problem. It could be a tire problem. It could be a suspension problem. Okay? Those can also affect this. Play of the steering wheel. Feedback, right? The numbness. Maybe I'm going to have vibration or shimmy in that. Maybe my vehicle's pulling to the left or to the right if I'm not holding the steering wheel crooked. Okay? If I let go of the steering wheel, does it return properly? Okay, are there noises that are not there? What do those noises sound like? So there's a bunch of different questions and things that we need to be able to focus in on, because this is why you're getting paid money to do this, right? They brought it to you because they don't have the education to understand all these systems. And they're relying on your expertise and just trying to figure out what's going on. Okay? And again, the tests and everything that we're going to end up doing is going to obviously allow you to pinpoint what potentially is wrong. All right, bleeding or purging power steering system is going to remove trapped air. Because most of our hydraulic system requires a liquid to be pressurized. If there's any air in the system, air can be compressed, liquids cannot. So if I have air in the system, that's going to cause my system not to function properly. I'm not going to get the pressure. So, customer might be complaining about a noise. Their fluid level might be good. Their condition might be good. They might just have some trapped air in their system. Okay, time to bleed that out. You have to know the process of that. Now, I'm not going to teach you how to do that. It's not overly complicated, but it's not going to be in the scope of what we're doing in Auto 1. System service also often includes flushing out the old fluid and replacing it with new. Again, this is a service that is typically done at certain mileage of the vehicle, not as frequently as an oil change, but it's something that you want to flush out the old stuff, put the new stuff in. Again, it's a hydraulic system. In order for our pump to be working adequately, we want to make sure that that fluid is lubricating it and it's working the system as it is. If we run it dry, it's going to cause the pump to overheat and fail. All right, last slide. Power steering pressure tester helps determine pump and valve problems. Again, typically that PSP sensor, power steering pressure sensor, I can actually disconnect it, hook up at my own gauge, run the power steering system, and actually measure that gauge out. Does that gauge corroborate with what the sensor is telling the computer? If that sensor is lying to that computer, the pump might be just fine. I might need to actually electronically replace some stuff. And again, there could be some diagnostic trouble codes that could pop up, depending on the type of system that you have. But typically, DTCs are going to be more emissions related. Actually, they always are emissions related. All right, we don't need that. All right, listen, we got 3 minutes. That's enough time to write down 3 questions in your notebooks about today's presentation, about power steering systems, electronic or hydraulic. We're going to give you guys that time to do that. That way we can come in here tomorrow and be ready to rock and roll.
We've had this question in my notebook for quite a while.